So now that we know how to graph linear functions, let's graph more complicated functions. Over here, we have a function that is x squared minus 3x plus 4, and if we just want to graph it, we can just calculate a bunch of points and then graph those points. So let's do one. So let's see, f of 1 is equal to, well, what's 1 squared? Minus 3 times 1 plus 4. So 1 minus 3 is minus 2. Minus 2 plus 4 is positive 2. Okay, so there's our first point. And then let's do negative 1 is equal to negative 1 squared is 1. Minus 3 times negative 1 is plus 3. And then plus 4 here. That gives us 4 plus 4 is 8. Let's do f of 3. And then, so 3 squared gives us 9. Minus 3 times 3 is minus 9. And then plus 4 gives us positive 4. And then let's also do negative 3 here. So if we have negative 3 squared gives us positive 9, negative 9. And then plus 4, so 0 plus 4 is 0 once again. So let's see if this is enough points to graph here. So we have 1, 2, and then we have negative 1, 8, and then 3, 4, and then negative 3, 4. Let's just graph these points and see if we can figure out the behavior of the function. So 1, 2, there we go, negative 1, 8, 1, 2, 3, 4, 5, 6, 7, 8, all the way up there. And then we have 3, 1, 2, 3, 4, 1, 2, 3, 4. And then we have negative 3, 1, 2, 3, positive 4. I don't know if I did that right because that does not make sense with the shape of the function. So, oh, I see what I did. Okay. So negative 3 times negative 3 would give us a positive 9. Okay. Positive 9. So 9 plus 9 is 18. And then 18 plus 4 is 22. So we don't even have 22 ticks on a graph, but we know it'll be way up here. And so if that gives us 3 points. Let's do 0. What is f of 0? Because we can kind of see a shape, but it's still confusing. Equals 0. Minus 0 plus 4. So 0, 4 is our point. 1, 2, 3, 4. Okay, well, let's just kind of draw a line through these. And it goes back up on either side because the higher you get, the higher the number gets, and same in the negative direction. So this is what's called a quadratic function. Whenever we have an x squared as the highest variable of x, it'll give us a shape like this here, or a shape like this for negative x squared. And we can talk more about the quadratic functions. Two important aspects of this function are this point down here, which is called the vertex. And that's basically where the function comes and then reverses direction. And it should be symmetrical on both sides of this point, meaning that both sides, if you look out, should be a mirror image. And then there's two more important points. This function here that we drew does not have any solutions, but a solution is like the x-intercept of a quadratic function. It's basically where the function will, let's say this is the vertex. It's where the function crosses the x-axis. So this is a solution, and then this is another solution. So like we calculated the solutions of quadratic equations, how there was two solutions, there are two solutions when we calculate the solutions of quadratic functions. But let's go ahead and do an example where we're given a quadratic function and we want to find algebraically, using algebra, we want to find the solutions, the two solutions, and also the vertex. When we're solving and graphing quadratic functions, we have an important tool which is known as the quadratic formula. The quadratic formula is what is written up here, and what it means is any function in the form f of x equals ax squared plus b times x plus c, we can take those values in the function, plug them in here, and it will give us the two solutions of the function, aka the 2 points where the function crosses the x-axis and where the function is equal to 0 in the y direction. But let's try it with the given function over here. So I'm going to rewrite this over here. F of x is equal to x squared minus 3x minus 4. So our a value is just 1. Our b value is negative 3. And our c value is negative 4. So if you have a function that's in a different form than this, or it's switched around, just switch it to look like this form up here, and then you can grab the values. But let's plug the values into our quadratic formula to give us a solution. Solutions, plural, equal negative our b value, so negative 3. This needs to be way longer, plus or minus. That's where we get the two solutions, because we eventually have to break it into a plus and a minus. The square root of b squared, so negative 3 squared minus 4 times our a value times our c value. You see how I'm just substituting in the values we got, all over 2 times a, so 2 times 1. And we can simplify this more, so x is equal to negative 3 is positive 3, plus or minus. You can do this all in your calculator if you want. So it's basically negative 3 squared is 9, and then minus 4 times minus 4 is 16, so 9 plus 16 is 25, all over 2. And at this point, we know that the square root of 25 is 5. And let's break it into the plus and the minus. So for the plus, we have x is equal to 3 plus 5 over 2. And x is also equal to 3 minus 5. 3 minus 5 over 2. So if we finish simplifying this, 3 plus 5 is 8. 8 divided by 2 is 4. And 3 minus 5 is negative 2. Negative 2 divided by 2 is negative 1. So these are our solutions for the quadratic function. Once again, what that means is these are the points in x where the function crosses the x-axis and where the function is equal to 0. So 1, 2, 3, 4. That's one of our solutions. And then x is equal to negative 1 is also one of our solutions. So what this quadratic formula basically does is it finds where our function is equal to 0. Basically, it factors it. But when the function has different values and we're unable to factor it manually, it factors it for us. And as you can see, if we factor this expression up here, this function, we can factor it as x minus 4 times x plus 1. So you can see that if x was equal to 4, 4 minus 4 is 0, that would make our function equal to 0. And also, if x was equal to negative 1, negative 1 plus 1 is 0, that would also make our function 0. So this is basically a calculator that will find us where our function is equal to 0. Now, up here, we have what's written as h is equal to negative b over 2a. This is a version of the quadratic formula that will get us the vertex. Remember, that's the point where the graph, the function, switches around. It's the very bottom or the very top of the function, and that is also useful. So let's go ahead and calculate that. I'm going to calculate it over here because that's where I have the most room, but negative b, h is equal to negative b, so negative 3 all over 2 times a, so 2 times 1, and this gives us 3/2, which is equal to 1.5. Now, this is the x value where our vertex is. Remember, the vertex is not on the x-axis. It is somewhere else. So we need to find the y-coordinate of this point. We have the x-coordinate, but how we find the y-coordinate is we just plug this 1.5 in as the x value of our function. So if we want to plug 1.5 into our function here that was given to us, we can just say f of x, or f of 1.5, right? We're just going to substitute it in, is equal to 1.5 squared minus 3 times 1 times 1.5 and then minus 4. And this, if we simplify it, will give us our y-coordinate. So let's simplify that. Is equal to 1.5 squared is 2.25. You can do that on your calculator. Minus 3 times 1.5 is minus 4.5. And then minus 4. If we add this up in our calculators, that'll give us, let's see, that will give us minus 8.5. That will give us minus 6.25, I believe. So this is our y-coordinate for the vertex. So we have our x-coordinate, our y-coordinate, and we can write this as a point as 1.5. And then minus 6.25. So now, if we graph our vertex, so 1.5 in the x direction, and negative 6.25 in the y direction, 1, 2, 3, 4, 5, 6.25, just about right there. If you'll look, the vertex is right in the middle of our two solutions as far as the x. So at this point, we can draw a line through our two solutions from the vertex. And that is how we graph a quadratic function. And we got our solutions and we got our vertex. But let's do some more examples to get comfortable using the quadratic formula. In this example, we can solve the given function, -1/2 times x plus 2 squared plus 4. But first, we need to get it in the form ax squared plus bx plus c. So let's just rewrite this as -1/2 times x plus 2 times x plus 2 plus 4. Just keep simplifying. So -1/2 times x squared plus 2x, and then plus another 2x, and then plus 4, and then plus 4 on the outside of the parentheses. So f of x is equal to -1/2 times x squared, and then we can combine like terms here, so that's equal to 4x. -1/2 times 4x gives us -2x, and then -1/2 times 4 gives us -2, and then we have a plus 4 over here. So we almost have it in the form ax squared plus bx plus c, but let's just rewrite it. -1/2 x squared minus 2x, and then plus 2. So we can get our three a, b, and c values. So a is equal to -1/2, right? And then our b is equal to -2, and our c is equal to +2. Excuse me, that's messy. So -2, c is equal to +2. It's important to try and stay as neat as possible when you're doing stuff like this, because messiness makes mistakes, especially for me. But let's bring this all up here and calculate the quadratic formula. So we have x is equal to -b, so -2, and then we have a plus or minus. Our square root here is b squared, so -2 squared, and then minus 4 times a, which is -1/2 times c, which is 2, and then all that is over 2 times a, so 2 times -1/2. We can rewrite this as x equals +2 plus or minus. I just do this all in my calculator just because I don't want to have to rewrite this a million times. So -2 squared is +4, so -4 times 1/2 is +2, 2 times 2. So this whole thing is 4 plus 4 is 8. So square root of 8, if you do that in your calculator, that'll give you like a decimal number. Let me calculate it real quick. I'll be right back. Okay, so square root of 8 is 2.83, rounded to 2 decimal places. So don't forget the bottom here. So 2 times -1/2 is -1. Let's split this into plus and minus. So x is equal to 2 plus 2.83, and then we have a minus 1 here. And x is also equal to 2 minus 2.83 over -1. So x is equal to -4.83, and -0.83 over -1 is equal to 0.83. So those are our solutions, also where the equation or the function crosses the x-axis. So we can graph those out if we want. So -1, 2, 3, 4, almost -5. Once again, your graphs are not going to be exact, but it's good to kind of have a visual on what it will look like. And then we also have positive 0.83, so almost 1. Now we have our two solutions, and we just want to find our vertex, so let's use this formula here. So h is equal to -b over 2a, so -2 over 2 times -1/2. And that gives us positive 2 over -1, so it gives us -2. And if you look, -1, -2, it's just about in the middle of our 2 points. So we know that, well, that's not the vertex, that's just the x value. We need to plug it into our function in order to give us the y value. So I'm just going to bring all this back over here so I have more room. So we're trying to find f of -2 to give us the y value of our vertex. F of -2, so -1/2 times, I'll just plug it into here because that's easiest. So -2 plus 2 is 0. That'll be easy. Squared. And then plus 4. Excuse my messiness. So 0 here, and it will give us a plus 4. So the f of -2 is equal to positive 4. So what this means is our x value is -2, our y value is -4. That gives us the point -2, 4, and we can graph that, and that is our vertex. So -2, 1, 2, 3, 4. So now that we have the vertex and the two solutions, we can draw a line through them, or a kind of parabola, it's called. The parabola is this shape here, the curvy. And that is our graph for the function. And we have our solutions for the function, and we also have our vertex. This will be useful in the next lesson for solving real-life problems. So here we're given another quadratic function, but real quick, before we do the quadratic formula, I want you to just look and see what would make this function equal to 0. Positive 2, right? And so positive 2 will be a solution, but we can use the quadratic formula to confirm that. Let's go ahead and just multiply this out. So f of x equals ax squared plus bx plus c is the form we're trying to get. F of x, I'll rewrite this multiplied out, equals x minus 2 times x minus 2. So if we multiply that, gives us x squared, and then minus 2x, and then minus 2x again, and then -2 times 2 is positive 4. Let's combine like terms. So we have x squared minus 4x plus 4. So we have our a is equal to 1, b is equal to -4, and c is equal to plus 4. Let's do our quadratic formula over here. X is equal to -4 plus or minus our square root of, let's see, b squared, so -4 squared minus 4 times our a value, which is 1, times our c value, which is also 4. all over 2 times 1. And so if you calculate this, that's actually equal to 0. And so what that means is both of our solutions are exactly the same. And this is confusing, but I'll explain it in a second here. So we're left with x equals positive 4 plus or minus 0, right? So both our plus and our minus will be the same point, over 2. So that gives us 2. And would you look at that? That's exactly what we guessed from earlier when looking at what would make this function equal to 0. So what that means is there's only one point in the entire function where I'm going to draw a parabola down here. So there's only one point in the entire function where there's not two parts of the function going through a horizontal line, and that is this point that is the vertex. If it was any other point, there would be two solutions. So based on this, we know that the vertex is exactly on the x-axis. So our vertex, if we did the same formula in here, it would also give us 2. So the easiest way to graph this is just to plug in some other points. So let's do 1. So 1 minus 2 is negative 1. Negative 1 squared is positive 1, so 1, 1. And then let's do 0. So 0. 0 minus 2 squared is 4. Look at that. So 0, 1, 2, 3, 4. Let's do 3. So 3 minus 2 is 1. 1 squared is 1. So 1, 2, 3, 1. Let's do one more point. Let's do 4. So 4 minus 2 is 2. 2 squared is 4. And so 1, 2, 3, 4. 1, 2, 3, 4. And so we kind of have this parabola shape enough to graph it. But now you know that whenever you get a 0 in the square root, that means that the vertex is on the x-axis. And so we have both solutions, and the vertex are 2, 0. And our solution is x is equal to 2.
Hey guys, if this video has been helpful to you, click the link in the description to get access to the complete Easy STEM Algebra 1 system, which includes a textbook, homework, and all of the course videos in order.